Welcome to my video on adding and subtracting using significant figures. In our first example, we have 3.5 plus 51.028. And if we just do the math and we add these two numbers together, we get an answer of 54.528. However, your homework tells you that you need to round using significant figures. Or maybe you're conducting a lab experiment, which you also need to round using significant figures. And how do we do this? Let's take a look at these numbers that we just added together. We have 3.5, which is accurate to the nearest tenth, and we have 51.028, which is accurate to the nearest thousandth. Now our final answer can never be more accurate than any of these numbers. Since 3.5 is only accurate to the nearest tenth, that means that our answer cannot be more accurate than the 10th position. So basically, any number to the right of this line I just drew cannot be in our final answer. So our last digit is going to be this 5, and we can use a number to the right of it for rounding purposes. Since 2 is less than 5, then the number stays the same. We don't round up. So our final answer is going to be 54.5. Let's move on to our next example. Here we have 17 minus 14.262. And if we do the math and we subtract these two numbers, we're going to get an answer of 2.738. Now once again, if we're rounding using significant figures, our final answer cannot be more accurate than any of the numbers. So since the number 17 is only accurate to the nearest ones unit, then our final answer can't be more accurate than the ones unit. So I'm going to draw a line just to the right of the ones unit, and all the numbers to the right of this line cannot be in our final answer. And we can use the number to the right of the 2 just for rounding purposes. Since 7 is greater than 5, then we're going to round up. So the 2 becomes a 3. So we have a final answer of 3. So now let's move on to our last example. This type of problem seems to make a lot of students angry, and it made me angry as well before I understood why we really need to use significant figures. So let's get started. We have 50,000 plus 4,000.0. And if we do the math and we add these numbers together, we get a final answer of 54,000.0. So now let's go back and take a look at these numbers we just added together. We have this number 50,000, which does not have a decimal point. So that means that the only significant figure is this number 5, which is in the 10,000s unit. So what this implies is that whoever measured this number 50,000 must have used a tool that was only accurate to the nearest 10,000. So now let's take a look at this number 4,000.0. This number does have a decimal point, so that means that this number 0 is significant. And what this implies is that whoever measured this number 4,000.0 must have used a tool that was accurate to the nearest tenth of a unit. And it just so happens that the measurement was exactly 4,000.0. So now let's take a look at our final answer. Our final answer can't be more accurate than any of the numbers. So since 50,000 is only accurate to the 10,000s unit, that means that our final answer also cannot be more accurate than the 10,000s unit. So that means all of these numbers to the right of the 5 we cannot use. And we can use this number 4 for rounding purposes. Since 4 is less than 5, then we keep it the same and we don't round up. So we still have this number 5, and the rest is all zeros. So our final answer is going to be 50,000. So I hope this video gave you a better idea on how to add and subtract using significant figures. I have many other videos on significant figures as well, so if you need any extra practice, make sure that you watch them. I really hope that you're enjoying these, and I will see you in my next one.